My name's Tejas, and welcome to the screencast of my third year project, which is music generation from images using processing. In this screencast, I will provide the motivation behind doing this project, some relevant context, and demonstrate three main ways that a user can interact with the system, namely how a user can experience the musical representation of an image they choose, view histograms of the image's color properties, and make changes to the music and image in real time. Image-based music composition approaches in the past have often been very computationally inefficient, and produced musical results which are not very pleasant to listen to. Therefore, this project aims to provide a method of generating adequate sounding, musically coherent audio, without the expense of computational efficiency. Over the year, I have developed a system that analyzes the color properties of a static image and subsequently generates a musical loop. Specifically, my system will analyze an image under the HSB color model. Histograms will be created from the image's hue, saturation, and brightness values, and this data will be used to select appropriate musical samples that I have recorded using external digital audio workstation software. In this case, samples are simply audio files for target output. This system was designed using processing, which is an open source visual arts and graphics sketchbook and language. Processing contains many helpful library functions for working with visual and audio-based data, and the object-oriented nature of Java was incredibly useful in helping me keep track of the types of data I was working with. In the HSB color model, hue refers to the angle between 0 and 360 degrees on the hue color wheel, which determines what pure color a pixel has. Saturation refers to the quantity of a hue present according to this spectrum. From left to right, the saturation of red decreases from 100 to 0, and brightness refers to the tendency of a hue to emit light. The most light is emitted at a value of 100, whereas the least light is emitted at 0. Together, these properties can be represented as a color cone. During development, I had also considered using the RGB color model as shown in the cube. However, noticeably changing hues in the HSB color cone is a lot easier to do, since only the hue parameter needs to be modified. If I wanted to make a similar change in the RGB color cube, I would most likely need to modify at least two parameters, if not all three. The HSB color model therefore allows an easier description and comparison of colors. Now I'll discuss how the color attributes in an image are associated with musical properties. The musical style I have integrated is chill hop, a genre that blends elements of traditional jazz and hip hop to create unique sounding instrumentals. These instrumentals primarily consist of the following elements: a melodic instrument, a chord progression, which is an organized set of musical harmonies, and a continuous loop of a drum sample to provide rhythm. The properties of the generated histograms will provide the musical qualities of the loop in the following ways. When analyzing the hue histogram, the average value of the 7 most common hues will determine the type of melodic instrument. In the saturation histogram, the most common saturation value, which is determined by the highest peak, will be mapped to a tempo measured in beats per minute for the drum sample to be played at. And in the brightness histogram, the most common brightness value, also determined by the highest peak, will be mapped to a tonal center number, which obtains a chord and its corresponding neighboring chords according to the circle of fifths. I will now demonstrate the three main ways a user interacts with the system. First, the user is prompted to select an image in either JPEG or PNG format, like so. As soon as they see the image, they immediately hear the musical representation of the image, as you hear now. As mentioned, the hue, saturation, and brightness values of the image have determined the melodic instrument, drum tempo, and chord progression that are playing at the moment. While listening to the music, the user can view the histograms of these properties, like so. In this particular image, the most common hues are from a large variety, as you can see. And since the most common saturation value is very high, this corresponds to a fast drum tempo. The user also has the ability to load another picture to see how different the music might sound. So as you've probably noticed, this picture's musical representation is slightly different to the one before, and here's why. Unlike the first image's noticeably wide range of hues, the most common hues here are mainly derived from orange, which is why a guitar was chosen as the melodic instrument, as opposed to a synthesizer. The most common saturation value is lower than the first image, therefore the drum tempo will be slower. As we can see here in the brightness histogram, the most common brightness value is higher than the previous image, therefore the chord progression is different. To increase interactivity, the user can change the drum tempo in real time and reveal the newly saturated image, like so. That concludes my screencast, and thank you for watching.